I welcome you all to this project group discussion. So, Rahul, share the screen.
Sir, it is sharing, sir.
Yeah. Please tell me what is the first point. I think you can zoom it. Otherwise, Rahul, please tell me the thing. I will discuss that. Okay.
Sir, we'll start with the object of the project, our the third
Your voice is not clear.
point, sir. Start with
Sir, start from third point, sir.
Start from
Third slide, sir. It's about the objective of the project and expected outcome, sir.
yeah. Okay. So we are considering the pulse oximeter, the problems associated with the pulse oximeter is that the main objective is to estimate a reliable and accurate blood oxygen saturation, that is SpO2. Reliable and accurate estimation of blood oxygen saturation is the first parameter that can be derived from pulse oximeter's photoplethysmographic signal. Second one is the PPG signal, that is photoplethysmographic signal, is in synchronism with the electrocardiogram signal. The ECG signal and PPG signal are asynchronous. So the meaning is that ECG signal will be used to find the heart rate of the patient. Similarly, can also find the heart rate from photoplethysmographic signal because both ECG and PPG signals are asynchronous. The beat to beat spacing is sync with PPG signal. You can see this in the one of our papers, IEEE papers, where we have provided the synchronism between ECG, PPG, and BP in one of the paper. You can see that. So heart rate can be calculated from photoplethysmographic signal. Next one is heart rate variability, HRV analysis. These are the things can be done. We are not saying that we are doing these all things, but the next parameter is heart rate variability. In general, the heart rate will not be constant for a individual human being. It will always differs when you are walking, when you are running, when you are sleeping, doing other activities. So every activity will have its own rhythm, will have its own heart rate. So heart rate variability is one of the important parameter to identify the condition of the patient. But however, we are not concerning with that. We can we can calculate those parameters. Next one is extracting respiratory information. That is, breathing in and breathing out can be identified using a chest belt sensor which is attached to the chest of a human being, which causes lots of discomfort to the patient. So, respiratory information is also useful in some diseases like sleep apnea, snoring, some important uh, diseases that can be identified from the respiratory information. The beauty of ECG and PPG signal is that the beauty of ECG and PPG signal is that the respiratory signal is modulated. We can say that one. I can say that while you have studied the analog communication system, will generally take M of t is a message signal or modulating signal, C of t is a carrier signal, and we say SAM of t, amplitude modulated signal. So the ECG signal and the PPG signal can be look like a AM FM modulated signal. It consists of both amplitude variations and frequency variations. Then obviously one question generally comes into picture that while I'm discussing this, what is the message signal, what is the carrier signal? If I consider ECG, ECG signal is a carrier signal, respiratory is a message signal or modulating signal. So respiratory signal is embedded in either ECG or PPG signal in the form of AM, FM, amplitude modulated and frequency modulated. So we can also get the information of respiratory signal from the recorded PPG signal, which will eliminate additional sensor to acquire respiratory information. In general, the respiratory sensor will be causes lots of discomfort to the patient because it's a chest built sensor. So we can use PPG signal information to acquire the embedded respiratory signal. So these are the things, the information that is embedded in PPG signal. And the important problem associated with PPG signal is that it is motion artifact. We call it as a noise because of voluntary or involuntary movement of finger. So generally we may place the PPG sensor either to a finger or earlobe or some parts of the body which can be read from the literature. So once you place it to a finger, there are two types of pulse oximeters. One is reflectance pulse oximeter, another is transmittance pulse oximeter. You can read this from any book, any literature book related to PPG. So, reflectance type, transmittance type. Either of the cases, you have red LED, IR LED, and opposite side you may have photo detector. So when the red and IR light passing through the finger tissue, the variations in the light can be detected by the photodetector, leading to a photoplethysmographic signal. Because of unwanted movement, but it may be happen sometime voluntarily or involuntary, leading to a motion artifact noise, resulting in erroneous estimation of blood oxygen saturation. So that is one of the important objective we can say. And second objective I can say that besides reducing the motion artifact or besides eliminating the amino acids, we should not lose the embedded respiratory information. We should not lose embedded respiratory information. Here one important point come here that in general the respiratory signal frequency will be in the range of 0.2 to 0.33 Hz. General case 0.2 Hz to 0.33 Hz. So noise may the MA noise may be in this range. MA noise is a random component. It may exist at any frequency, and if suppose it is existing between 0.2 to 0.33 Hz, which is called in-band noise. That is, both signal and noise are in same frequency band. Then we call that scenario as in-band noise. I discussed this issue with other time with Rahul while taking the problem of band pass filter and low pass filter discussion. So classical low pass, band pass, high pass, band reject filters will fail to eliminate the in-band noise. Fail to eliminate the in-band noise. So my primary objective here is that reducing the motion artifact, preserving the respiratory information. Final aim is accurate and reliable estimation of blood oxygen saturation. This is my main aim and objective. Then, Rahul, please tell me what is the next one I should discuss.
Sir, proposed method and justification, sir.
Yeah, proposed method. So here we still we have not finalized that. When you have presentation actually
Sir, 17th, sir.
17th, so it will be on Friday. I will most probably give the title exact method what we'll do by today night.
Okay, sir.
I will search it out in the internet and some IEEE papers, and I have some ideas, but before giving it to you, I want to check it out. Then I will come up with a best option.
Sir, existing algorithms and processes, sir.
You can give all the reference papers. You can read. I think our
Yes, sir. We will
our
make it.
ASLMS paper and
Yes, sir.
similarly some latest papers
Reference
are.
paper and principles of paper and a couple
Yeah,
of
yeah,
other
yeah.
papers.
Those methods. Besides that, mainly concentrate on others' method, not our method. Okay. You just type in the Google PPG and motion artifact reduction. You'll get nearly some 30 to 40 papers. Just give a one-line information about top 5 to 6 papers. Preferably, you refer papers related to IEEE transactions. It may be IEEE transactions on instrumentation and measurement, IEEE transactions on biomedical engineering, IEEE transactions on biomedical circuits and system processing, likewise, and Elsewhere and Springer. Top journals, you just refer. I think existing methodology, you may give some 5 to 6 references and briefly one line explanation related to that paper should be addressed in this point.
Okay, sir.
Okay, sir. Sir, software and hardware requirements. I wrote software as MATLAB.
Yeah,
Hardware is
MATLAB
Max.
hardware. You may provide information that in our research laboratory of E&I engineering, we have pulse oximeter. So the biopack, generally you just get the information from Venu Maheshwar sir. What is the laboratory equipment which is available in our research laboratory and specifications of that equipment. I think a biopack system is there in the lab.
Yes, sir. Biopack.
Yeah, so you can get the specifications and other information, technical information related to the biopack from Venu sir.
Sir, Max 30100 module, no need.
I'm not getting Rahul. Max.
Max 30100 module. We have referred to that itself.
Okay. Whatever you have referred that is there in the laboratory, you just mention those specifications, technical specifications related to that device in your presentation.
Okay, sir. Then after getting into the details of like which proposed method we will be using, we will get into limitations of the method and advantages of the method, sir. Then it will be fine.
You might have come to a conclusion the advantage limitations and all those things in this first seminar. You
Yes,
better
sir.
that we are thinking in the direction to work with this.
Eliminate the motion artifacts in a much better way than the existing algorithms. This
Yes,
could be
yes,
the
yes,
case.
yes.
Okay, sir.
So as to reliable and accurate estimation of blood oxide saturation.
Okay, sir. Then the first things we will do that, and the next like core information about the proposed methods we will discuss after the after your words, sir.
Okay. By just give me a WhatsApp message after around 7:30 or 8,
Okay,
informing
sir.
that relating to our proposed method discussion. So I
Okay,
will
sir.
finalize it by night.
Okay, sir. I'll call you after that so that if any problem is there, I'll discuss it then and there.
Yeah. Done.
Okay, sir. So please provide the recording, sir. We will conclude this meeting now.
Yeah. So